Hi folks, welcome back to Math with Captain Rod. I'm on my third attempt here at making this review for you. I keep making the review, it's about 20 minutes long, and then I go back and look at the video and the darn computer screen is not recording the portions I need it to record. Hopefully this time it's working. I think I got something here that's going to be good for you. So let's go through this test here and talk about the important things here. So the first couple here are about how to evaluate limits. And rule number one is you just put the number in this case 0 here, into what you're trying to find the limit of and see if you get a number out. And if you do, you're done. If not, if you get something like this one where you get 0 over 0, you got to do some monkeying around with it, I guess, if you will. Now, there's several different limit proofs. One of them is to identify the highest power of x that you see, in this case x to the fourth, and then divide it out of everything. So basically what we're going to do is take this thing and do 1 over x to the fourth over 1 over x to the fourth. So you do this times this times this, and this, and again, this is still limit as x goes to 0. You should get something out of this that you can identify at that point. Now, if the problem looks a little fancier, like it's got some parentheses here, like to the 1/3 or something, well then the highest power is effectively x to the 4/3, and you do the same exact thing. So that should get you out of this one. Okay. Next one, limit as x approaches tangent x. So write it sine x over cosine x. Take the limit as x approaches pi over 2 from the left, keep in mind. And that should give you an idea of how to do that. Okay, 3 and 4. So limit as x approaches 5. Now this is a constant. This is going to 0, which means the limit is infinite. But you got to decide plus infinity or minus infinity. Now keep in mind this is 5 from the right. Those are numbers like 5.1, 5.01, 5.001. So then this is going through 0. Then you decide through positive or negative values, and that will determine whether it's plus or minus infinity. Next one here, break this up into two limits, one being x over, I'm just going to put sine x cosine x, plus, then the other one is going to be limit as x goes to 0 of x cosine x over sine x cosine x. These will divide out, and that should give you, that should get that one done. Okay. Epsilon delta proofs. This will be the 5th time I've went over this because I've done this twice in 2 previous videos, but let's start with this. This is a linear function. I'm just going to assume m is positive for now. It won't make any difference in this video. Here's the, again, the idea behind an epsilon delta proof, right? When you're trying to do a limit, and although this doesn't even say epsilon delta proof, it still effectively is. The idea is for any epsilon that somebody gives you, you can find a delta such that when, as long as x is in a certain range, all right, so let's call x sub o, and then this would be x sub o minus delta, x sub o plus delta. As long as x is in this range, the function is closer to the limit than L plus epsilon, L minus epsilon. It'll make a little, I hope it makes more sense when I draw my picture over here. What I usually do with these is I take it by side here. So this is 2. Now here is our limit, which would be 2m plus b, just by putting a 2 right there. All right, now, if I go to the left by an amount 2 minus delta, this is now m times 2 minus delta plus b. That's the function value evaluated there. Now I imagine going to the right by 2 plus delta. Our function value is m times 2 plus delta plus b. Okay, now here's the idea. And again, let's take left and right hand side. Imagine we're here. Here's our x value. Notice that that x is to the right of 2 plus delta, which allows us to write an inequality statement. X right of 2, and I'm sorry, I said plus, but I meant minus, 2 minus delta. And notice that the function is above this, which allows us to write the following. Mx plus b, our function, is greater than m times 2 minus delta plus b. Now, if you solve this one for x and compare to this, that should allow you to write a statement that says it'll look like you should end up with delta less than and some expression with epsilon in it. And yes, it'll be less than, not greater than, because you'll notice when you finally solve this for delta, there's a minus sign it'll reverse the inequality direction. So basically what you'll have here is you'll have a delta on the left-hand side. So for example, this is some expression and you need delta less than that. Well, this expression over 2 would qualify, or over 3, or over 100, or whatever would be less than. So basically that means I have found a delta that's good on the left-hand side. Then you do the right-hand side. So we pick a point. Here's x. Now, you notice x is to the left of 2 plus delta. That means x less than 2 plus delta. Also notice the function is smaller than this value, which means our function mx plus b less than m times 2 plus delta plus b. If you solve this one for x compared to this, you should be able to get another delta. It'll read delta less than some function of epsilon. You're going to find in this one, I believe these will be the same, so you'll basically be done. And again, you're done because for any epsilon somebody gives you, you have a delta that keeps the function in its appropriate range. Asymptotes, definitely be a question like this on the test. So notice that the top and the bottom are of the same power. So this thing is going to have a horizontal asymptote. You find it by taking limit as x goes to infinity of this expression. You're going to get, some positive number for that. Then you sketch it on your graph. Y equals whatever that number is. This one has potential for a vertical because those occur where the bottoms end up equaling to 0. So hopefully it's fairly obvious where. Sketching your vertical asymptote. And we'll just, for grins, I'll just do this. Let's assume it's about there. Okay. Then you can typically just plot 1 or 2 points and sketch the rest of the graph. If you have trouble with it, send me a text and I can help you practice this. Tangent lines. Okay, there's going to be a lot of this on your test. This is the most important fundamental on this test. So start with a sketch. Hopefully you recognize this as quadratic. Goes through the point 1, 0. Okay, x equals 2 we're going to put right here. Our tangent line looks something like this. And again, y equals mx plus b. All linear functions can be written in that form. So the whole point really of this first exam, the really important stuff here is how to find the slope of a tangent line. Now slopes, you typically need 2 points, y2 minus y1 over x2 minus x1. What we're going to do is we're just going to make up basically our second point. So we're going to imagine moving over a distance h, which makes the new x value 2 plus h, makes the new y value, I'm going to write this over here, 2 plus h minus 1 squared. Then you just do y2 minus y1. You got to calculate your y1 by putting a 2 right here, and then over x2 minus x1. Now what you're going to have is that your slope is approximately equal to some function of h. Then what you do is you take limit as h goes to 0 of whatever you have there, and you'll get a number out of it. Then that number goes here, and then you can use the point 2 and your corresponding y value, put here and here to find b. Tangent line for this function, same deal. You go to 1, 1. You imagine moving over a distance h, so the new x value is now 1 plus h. New y value is 1 over 1 plus h. Right, your slope is approximately equal to y2 minus y1 over x2 minus x1. Right, you're going to get an expression with h in it. Then your slope is exactly equal to limit as h goes to 0 of that expression. And you'll notice here, it looks like we should get some negative number, right? Then you say, all right, y equals mx plus b. There is your slope. Then you'll notice it goes through 1, 1 to get your b. Do not skip this work here, finding your slope, because that's what I'll be testing you on. The problem will definitely say show all work for full credit. Okay, another limit proof here. And again, all right, this thing is quadratic. Prove that the limit as x approaches 2 is 8. All right, so 2, 8. And again, here's the idea behind the limit proof. No matter what epsilon you are given, the question is, can you find a delta that keeps the function closer to the limit than L plus epsilon and L minus epsilon, right? You know, that seems a little, I'm sure, funny, but take a look at this. All right, so imagine a horizontal distance delta. All right, so this value now we're going to call 2 minus delta. Then this value right here we're going to call 8 minus epsilon. Epsilon is some small vertical distance, delta some small horizontal distance. And basically the limit proof is this. Can we find a delta such that as long as x is in this range, 2 minus delta to 2 plus delta, then the function vertically is in this range, 8 plus epsilon, 8 minus epsilon, meaning that the function is closer to the limit than this or this. That's basically how it works. Now, what you can do, or what I like to do, is write a pair, you know, look at it on the side here, like side by side. So here's x. And you notice x is to the right of 2 minus delta, which allows us to write an inequality. X greater than 2 minus delta. Also notice the function value is bigger than this value. That allows us to write this statement. Our function, 2x squared, is greater than 8 minus epsilon. Solve this one for x. It's going to be x greater than blah, 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 blah. Compare these two and solve for delta, and you're going to get delta less than some function of epsilon. We'll have a bunch of epsilons in it. And yes, it'll be less than because there's a minus sign here. Right? That's going to reverse that. Now what we'll have here is you'll then basically have a delta here, any delta less than this. So for example, whatever this is, if I take it and divide it by 2, I have a number less than this, okay? And what I would typically do is call that like a delta 1, and we'll just store that for a minute. Okay, right hand side. So imagine we're over here somewhere. There's my x value. Notice that x is to the left of 2 minus or 2 plus delta, so we can write an inequality, x less than 2 plus delta. Notice the function, right, that's this distance, is below this one. That allows another inequality, which is our function, 2x squared, is less than 8 plus epsilon. Solve this one for x. You're going to get x less than some function of delta. Compare basically these two, and you can come up with an expression that says delta less than, and you're going to get some function of epsilon. Now basically now you got two deltas, a delta 1 and a delta 2. In my mind the proof is over, because technically people will say, well, which one is smaller? Well, it doesn't really even matter. Either they're the same, delta 1 is equal to delta 2, in which case you have found a delta for any epsilon, or one of them is bigger than the other. But either way, you have shown that for any epsilon you're given, you have a corresponding delta that keeps you in this range, which proves the limit. Now, this particular stuff I think is really hard to understand, and it's also very difficult to try to teach in an online environment in particular. I don't put that much importance. When I look at the difficulty against the importance, it's not too crucial. So there's 2 of these on this test. Your test will have 1 of them. Right now, replace it with something a little bit more important, probably a find a tangent line type of problem. And I'm probably only going to weight it about 5 points. So just do the best you can, and we'll work on it throughout the course of the entire semester here. But we'll come revisit it. And as you get more knowledgeable about this stuff, it'll become a little easier. But anyway, let's go on here. Okay, find the value of a such that this thing is continuous. Look, remember the criteria for continuous is this. Limit As x approaches some value here, I'll just call it x above from the right, has to equal limit as x approaches some value from the left, has to equal the function value at that spot. Those are the criteria for equality, right? Just apply that criteria. I'd probably start with this, right? And that'll tell you what that limit needs to be numerically, right? And then you can do limit as x approaches from the right and be sure it's equal to this, and that should find your value of a for you. If you have trouble, yell, but this one's a lot easier than it looks. Okay, average rate of change. This is just another way of saying slope. Okay, so slope, remember, is y2 minus y1 over x2 minus x1. Now, make sure you understand what you're looking at. This is an interval. These are both x values. So let's call this one like x2 and this one x1. And you might say, can it be the other way around? Absolutely, doesn't matter. Okay, it's just important that you realize that's not an x and a y, it's a pair of x's. Take each of these x's, run it through your function, and calculate a y value to go with it. So now you'll have a y2 and a y1. Now you can calculate your average rate of change. All there is to that problem. Evaluate the following limit. If you put h equals 0 into this, you're going to get 0 over 0, which is indeterminate. Expand this out, simplify first, and it'll be no problem. Find the equation for the tangent line. So hopefully, we kind of recognize this. Y equals x cubed, has this shape. It's inverted because of the -1 and raised up 2. This graph looks something like this. We're going to the point 1, 1. There's our tangent line. Goes through that point. 1, 1. Sorry about the super crummy pictures. Your pictures should be much better than mine. Again, key fundamental concept of calculus here. Okay. You imagine moving over a distance h on our graph. Our new x value is 1 plus h. New y value is 2 minus 1 plus h cubed. The slope that we're looking for is approximately y2 minus y1 over x2 minus x1. Take the limit as h goes to 0 of that expression. You will get a number, which is our slope here. Right, so y equals mx plus b, that's what we have. That's the slope. Then use your x and y to find b. Now, some of you, especially if you've had a little bit of work with calculus, or maybe you started section 2, are probably saying, can I just calculate the derivative of this thing, which is minus 3x squared, and use that to get the slope? And my answer is going to be, you can, but you won't get full credit. The point of this test really is about this stuff here. Not how derivatives are calculated shorthand. The point of this stuff right now, and the most important stuff, is understanding what the derivative is and what it tells you about a function. I am going to expect all derivatives to be calculated kind of longhand like this. It's going to say show full work for full credit. I will restrict it to somewhat easier functions when I do that, but you are going to be expected to show full work. So that is going to be your method for finding slopes every problem on the first test. Another average rate of change. So one thing I want to point out, look at how many average rate of change and slope questions are on this test. Quite a few. If I modify in any way, shape, or form, I'll be adding more of those. That's the most important concept here for this exam for you folks. So this one's going to be paper pencil. You're going to get plenty of time. I want to test you mainly on what you know, not how fast you can do it, and I will give partial credit provided that you show correct work. So you can always go back through your old homework and look for problems similar to these as practice. And if you have any questions about content or specific problems, just send me a text, let me know. All right, so I'm going to call that good right here. I hope that this little review here is giving you a good idea of what to expect. Have a great weekend, and good luck on your test next week.